Hi everyone, my name is Gianluca and welcome to the dark art of container monitoring. Sorry if the title confused someone. I should have done a better job at looking at the schedule. I am a software engineer at Sysdig and I'm a core developer of the open source system troubleshooting tool Sysdig. So today we're going to talk about monitoring and troubleshooting containers, mostly with Sysdig. Let's introduce the problem of the year. Who here is using containers? Raise your hands. Production, development. Good. So we have a good amount. So why do we like containers? We like containers because they are isolated, self-contained, simple, and lightweight. These are all features that allows our workflows as developers or administrators to be improved. But for these exact same reasons, seeing inside containers is not easy at all, because they now put a further barrier between us and our application and processes that we want to monitor. So not only now we have the hypervisor and the virtual machine, but we also have the container. So the question that I will try to address today is, can monitoring and troubleshooting be effective with containers? And what are the best practices to do this? In particular, this talk is pretty much going to be live use cases of monitoring and troubleshooting container. We'll go through some of the most popular command line tools. Then I'll show you something a little bit advanced. And then we'll go to Sysdig with more use cases. Let's start with the demo environment that I have here, because my presentation is going to be pretty much live. I have a distributed Docker web application. So here I'm using, it's a simple WordPress application, if you guys are familiar with the content management system. And I'm using Docker Compose to spin it up. So for who's not familiar with Docker Compose, it's just a very simple cluster definition tool provided by Docker. And so you can essentially specify with a simple YAML configuration how your application will look like. This is the infrastructure as a code thing. So here I have three tiers. I have a WordPress tier that is running the WordPress Docker image. And inside the WordPress Docker image, I will find the Apache web server serving the PHP application itself. Then I have a MySQL tier, which is running the Docker image for MySQL, which of course is serving the MySQL database for data persistence. And then I have NGINX that provides a single entry point to this application on port 80. Why NGINX? Because I could scale out the WordPress tier, so I could have redundant copies of WordPress, but I still want essentially one single entry point to the application, and then NGINX does this, so it balances the traffic among all my WordPress backend containers. And the nice thing about this setup is that by injecting the Docker API entry point into the NGINX container, now I have a little process inside called DockerGen that will automatically watch for additions or deletions of WordPress containers and will automatically regenerate the NGINX configuration file so that NGINX will always have an up-to-date configuration in case my containers die or are rescheduled. So running this infrastructure is simple as doing Docker Compose up. And if I do this, this will essentially create me three containers, one NGINX, MySQL, and WordPress, that I can easily see here with Docker PS. So I see that I have these three containers. Let me quickly set up this infrastructure by going to my web browser. Let's give it a few seconds, okay, here. Let's quickly install it. Blog, admin, password is fine. Email, let me put my favorite email address. And once the setup is up and running, I can essentially visit my application from the web browser or even here from curl. So I can do curl-foo.bar.com and I can see the HTTP response. Now, this infrastructure seems a little bit too simple for me, so I want to scale up the number of Docker containers, or WordPress containers. So I'm going to do Docker Compose, scale, WordPress equal 4. What this will do, this will create me 3 additional WordPress containers. So now I have an overall interesting infrastructure to look at. And to keep the infrastructure up and running, let me run this poor man's version of a traffic generator by doing a bunch of curl in a bash loop every 100 milliseconds. So the infrastructure that I just showed you, to my eyes, look like a big mess. It's a big troubleshooting nightmare, because now I have all these processes running in different containers, and they are all talking through this layer of virtual networking. So in order to effectively troubleshoot this, I need to be extremely smart about what I'm looking to troubleshoot and how I am troubleshooting it. So let's start with the first point. What I'm interested in troubleshooting. Usually I find that the things that are the most useful are in this list. So one can start from CPU, memory, and disk, then go to network activity, file activity, move into application or system errors, and then switch to proper application activity, for example, transaction monitors. And this is, you can follow a top-down approach or the inverse, depending if you are a developer or an administrator. If you're an administrator, you'll probably care most about CPU and memory. If you are a developer, you'll care more about monitoring the transactions that your application serves. So these are the 5 things that one is interested in monitoring. And how can one monitor those? You can monitor those by doing troubleshooting like a pro, is what I call. So essentially, you need to take each system resource that you want to monitor, and you need to apply the good old troubleshooting tools that we've had around for decades. This slide is incredibly rich and incredibly helpful. It's done by Brendan Gregg. If you have never checked his website and you're serious about performance, you should definitely check out his material, because the guy is awesome. And so let's apply this approach to the 5 points that I just showed you before. The first item that I had was resource usage, CPU and memory. So if I see here, I see CPU in the right corner, and I can see that, as expected, top is there, right? So let me use top against this infrastructure. Let me open another shell. Let me make it bigger. And let's run top. Let me sort by PID. So if I run top here, I see all the processes in the system. So I see tons of Apache processes, along with the system resources that they are consuming, which is all cool. But if one is misbehaving, I don't have a clear way of seeing in which container this specific Apache process is living, because, of course, top is not optimized for containers. There are stuff that I can do. For example, if I add the cgroups column, cgroups is the Linux kernel facility that Docker uses to group together processes in the same container. So I can see that despite all these Apache processes having the same command line, they have different cgroups. And so essentially, each cgroup is named after the Docker ID of the container running. So by doing some tricks of this sort, I could essentially look up the container ID where the specific Apache process is living. But this is not ideal, in my opinion. And another thing that I'm missing, for example, look here at the PID column. Here I'm just seeing the process ID of the Apache processes outside the container. But if you've used containers before, you know that when you're inside the container, you get an internal PID, because you live in a different PID namespace, which can be useful for logging purposes or for doing inter-process signal communication. So I can use other tools that are more optimized for overall system resource usage in container. For example, with Docker, we have already seen that with Docker PS, I can see all the Docker containers in my system. And if I do, for example, a Docker stats with 1 container, or let's put 2, now I'll have a live view of all the system resources that my containers are using, which is nice, because you can keep an eye on how your containers in your host are behaving. And if I want to drill down into 1 container, I can, for example, do a Docker top, and I can use WordPress 2, for example. And with Docker top, I can essentially dig into the container and see the individual processes that are running here, along with the system resources that they are consuming. So this is nice, although I think there's something better might be done. Let's move on to the second point, which was network activity. Again, network is the big green box in the middle of the picture, and I can see that pretty much all elements are pointed at by netstat, which of course is the de facto troubleshooting tool for network connections. And so let's use netstat here. If I use netstat, I see a bunch of network connections, a lot. But notice how all of those are on port 80. So for some reason, I'm not seeing the network connections that are going, for example, from Apache to the MySQL container, because those should be connections on port 3306, which is the MySQL port. Why does this happen? This happens because containers are isolated. Each container lives in its own network namespace, so each container gets its own private set of virtual interfaces and connections that you cannot see outside the container, like in this case, because I'm running netstat in the host. So the obvious solution to this would be, okay, easy, let's run netstat inside the container. So with docker exec, I can run a bash shell inside my container, or of course I have just MySQL, and then I can type netstat. But of course, netstat is not installed. Why? Because for the previous slide, containers must be simple and lightweight. You don't want to install all your tool belt of system troubleshooting inside every Docker image that you deploy, because otherwise containers are going to become huge, slower, and then at that point you might as well just use a virtual machine. So of course, if I remember the name of the package where netstat was, I could install it, but I don't. And in some container images, you cannot even find package managers. So one trick that I could do for this case is to use this neat system utility called nsenter. This is a bit advanced, but nsenter allows you to execute a program inside the namespace of another process. So I could run netstat that is on my machine against the network namespace where the MySQL process is living. So if I grab the PID of MySQL, and then I do nsenter, I specify as a target the PID of MySQL, and then I do net, and then I do netstat. Now I see all the connections on port 3306 that with the initial netstat I couldn't see. But this is not something I would advise in production because there are too many manual steps, and this is, I believe, is a trick essentially. So what this tells me is essentially that most of these tools, while being extremely useful, they are not optimized for containers. So I want to spend the rest of the presentation talking about the little guy in the top right corner, Sysdig, which instead is optimized for containers. So Sysdig is an open source system troubleshooting tool that wants to be a TCP dump for your entire system. So Sysdig doesn't work with network packets, but work with system events. I'll define in a second what I mean by system events. Not only it allows you to capture the system events, but it allows you to filter them or run scripts on them. And as I said, it has native support for containers. So before looking at Sysdig in action, this is how Sysdig works. This is the typical architecture of your system where you have a single running instance of the kernel, and on top of the kernel, you have a bunch of applications, processes. Some of those are running outside the containers, others are running inside the container. Here I put Docker LXC, could be whatever runtime you want. But the nice thing about this is that regardless where these processes are living, they will interact with the kernel the same way, which is through the system call API. The kernel doesn't care if a process is running in a container or not. The kernel thinks about system calls. And so by leveraging this fact, Sysdig works by having a little kernel module that will fetch all the system calls in your system that all the processes are doing, and we redirect them to the Sysdig user space application that lives outside the containers and can live in a separate privileged Docker container or outside in the host. So by doing this, we are able to see everything that's going on in your system. And this pattern is incredibly nice because you can have Sysdig installed even on infrastructure such as CoreOS or minimal container host distributions where the runtime is extremely stripped. So let's see this in action. In its simplest invocation, Sysdig is not very user-friendly, I have to say. So he will print me on screen all the system calls that all the processes in my system are doing, which are not helpful to me. So the first thing I can do is to filter those. If I type sysdig-l, I get access to all the hundreds of filters that I can use to limit the scope of what gets printed on screen. So I can filter on file attributes, I can filter on network attributes, I can filter on processes attributes, and most important for today, I can filter on container attributes and even abstractions built on top of containers. For example, last week we just released Kubernetes support, so you can get crazy filtering all your Kubernetes entities. So how does this work in practice? It works that if I do sysdig and I put as a filter container.name equal to demo MySQL1, now I see a much more limited output on screen that contains all the events done by the MySQLD process inside the container named demo MySQL1, whose ID was this one. So depending on what I'm looking for with filters, you can do some pretty heavy and advanced troubleshooting. But sometimes this is still too much. So most of the times I would just like an overview of how my system is behaving. So in these cases, I can choose to have all these system events being processed by our Lua scripting engine that we call Chisels. And these scripts will process these events and will just print me a much more user-friendly output, such as this. So if I do -C and then I press tab, I see all the dozens of chisels that we support by default. These are very easy to write. They're just simple Lua scripts. We have a very easy, totally open API. And they can run, for example, the top file bytes chisel. And this will now show me all the I/O activity that is happening in my system broken down by the individual container and by the individual file. So now, all of a sudden, looking at all those system calls doesn't seem too boring. And this is an incredibly rich metric. I've played around with many Linux troubleshooting tools, and unless you get crazy with perf or system tap or something like that, getting the I/O broken down at the file level and at the container level is a very incredible metric that we are very proud of supporting in Sysdig. And so there are tons of chisels, and with chisel one can essentially follow this top-down approach to troubleshooting, and they are very effective. But there's another way, which sometimes is better, to interact with Sysdig, which is Sysdig. Sysdig is our curses-based Sysdig UI. So in its simplest form, it looks pretty much like HTOP. In fact, we ripped the color scheme of HTOP. So I see all the processes in my system, but notice how I get this pretty cool column here, container. So now containers in Sysdig are first-class citizens. So now I can see all my Apache processes with the container where they're running. And I can see finally also this column, for example, the vpid, which is the PID of the process as seen inside the container, which again, depending on what kind of troubleshooting you're doing, can be very useful. And I can filter on this. So I can press F4, and if I press MySQL, I can filter so I can get the resource usage that the MySQL container as a whole is using. So this view pretty much covers the first point of my bullet list, system resource overview or whatever there was. But if I press F2, I go into the views panel where I can apply different troubleshooting views to my system depending on what I'm looking for. So the second item in my list was connections, the network activity. So if I go to connections, now I'm seeing all the connections that are happening in the system by all containers. So finally, I have a holistic view of all the connections done by MySQL, WordPress, regardless of the container, which is something that Netstat didn't provide me. Along with the process, of course, and all the sort of volume metrics that you would expect. So with something like this, you can cover the network activity, although I'm not done with network activity yet. Let's switch to another view, for example, containers. If I go to containers, now I see an output that is pretty similar to the Docker stats one. So I see all at once all the containers in my system with the system resources that they are consuming, which is pretty neat. And if I select one, for example, the demo in GNX one, by pressing enter, I do what I call drill down. So we enter into the container, and now we are seeing the processes that are running in this specific container, which in this case I have nginx, and then I have dockergen, which, as I said before, is this little helper that watches the Docker API for new WordPress containers so that it will update the nginx configuration file. And once I'm inside the container, I can switch to a view, for example, connections, and now I just see the specific connections for this container, which can be very, very useful. But what I want to show you next requires going back to processes. And let me sort, for example, one column, network. And I can see that the nginx process seems to be doing a constant amount of network activity. So wouldn't it be nice, without going with TCP dump and seeing what kind of virtual interface is here, and sniffing, and then there, seeing what's going on this network connection? With Sysdig, it's possible because we sniff all the system calls. So if I press F5, I enter into echo mode, and I can see all the I/O buffers exchanged by the whole process, regardless of the connection, which in this case, not surprisingly, are a bunch of HTTP requests. In fact, let's follow one. I have here, for example, that nginx in the demo nginx1 container read from this connection these HTTP requests, get root from user agent curl, which is my traffic generator. And then nginx opens another connection and writes to it, to this endpoint, which is one of the WordPress container, writes the same HTTP request by appending the usual X forwarded 4 headers typical of a reverse proxy. So notice how we did. By passively sitting in a separate container, we were able to get this information, which again, this is one of the modes that I find myself as a system administrator to use a lot during my daily job, because there was a time where you could get by with TCP dump, but with containers and all the mess of these network namespaces and all the virtual interfaces, an approach like this is much, much more user-friendly. So the echo mode is definitely powerful. I had then in my list the file view. So if I press F2, I go into files. Oops, sorry. I have to drill up, so I go to the whole machine. And if I see files, now I'm seeing a view like pretty much like the chisel before, where I'm seeing all the amount of I/O done in the individual files. I can sort by number of files open, written, or read. So let's sort by bytes written. And I can see that pretty much all the WordPress container seem to be doing a fair amount of write activity to the Apache access.log. And wouldn't it be nice if I could see without execing to the container and tailing or grepping what's actually being written to this file? Once again, I can use the echo mode. So I can do F5, and this will show me the individual lines that the Apache 2 process is writing to the access.log, which again is incredibly useful and gets exponentially more useful if you run containers. The other item that I had in my list was, if I remember well, the errors. So if I now go to container errors, for example, I can see that all the WordPress containers seems to be doing a fair amount of file errors, 2, 3 per second. So let's dig into this. So press enter on 1, and this gets me to the single errors that all the processes in this container are generating. And the most popular one seems to be this enoent, which if you have ever done system programming means just no such file or directory. So someone in the container is trying to open a file that doesn't exist, which worries me. So let's drill down into the individual error. And not surprisingly, we can see that Apache is trying to open a file. And wouldn't it be nice if I could see what file Apache is actually trying to open? I can easily see this by pressing F5 and going to what I call the dig mode. So now I'm brought to the individual Sysdig events that are causing the specific error. So in this case, I can see that Apache is trying to open the first line, the file var www.htaccess, which then failed with enoent, which is incredibly useful because in this case, this was just the per directory web server configuration file, but I might not always be that lucky, and I might really spot a problem in production, which might cause a performance issue or something. And so with this, essentially, I cover the first 4 points. For the application transaction, there's something more that I want to show you. We have already seen a bit because we can intercept all the HTTP requests, so what's more than application monitoring application activity than that? But we can do more. So let me stop my traffic generator, and let's run this command line. If I run sysdig, let's use this, using the wflag on trace.escape, now I'm not getting the system events on screen, but they are being saved to a trace file that I can then analyze for offline usage. So I want, for example, to capture a sysdig trace file while I'm scaling up the number of Docker or WordPress containers from 4 to 5. So if I do 5, now I see that Docker Compose is starting a new Docker container here, WordPress 5, and all the activity has been recorded in this file. So if I now stop it, I have a compact trace file that I can use, that I can download on my laptop and inspect it. And I want to inspect it this way. I want to read it with trace.escape, and I want to run a chisel that we call spy users. This will show me all the processes that are being executed by which user and by which container for the whole duration of the trace file. So here I can see that Gianluca, which is me, on the host, ran Docker Compose scale WordPress equal 5. And then in blue, we can see the activity inside the container. So we can see that immediately after the container started, demo nginx1 executed nginx-s reload. So the configuration file was reloaded, which again is pretty cool. But what is more interesting to me is what's happening in the WordPress container. So in the WordPress container, I have all these initialization steps, which are part of the Docker entry point, which I always have a hard time troubleshooting because they are, most of them you can find on the Docker Hub are messy. And by doing this, look here, I can inspect what's actually happening. So I have that a bunch of sed invocations here on the wp-config.php configuration file, where all the configuration variables are being set. In fact, I can see db host, MySQL, db user, root, db password, and I can inspect all the initializations of the Docker container by passively sitting in a separate container without having to modify my Docker entry point and putting tons of echo, or set-x or whatever there is. So with an approach like this is a further addition to essentially application monitoring and essentially seeing application activity. And this is pretty much what I wanted to show you. Still have a few minutes, okay? So another question that comes often is, okay, all these tools are neat because they will show you how to troubleshoot your individual host, but most of the time in your daily job, you'll have to manage with dozens, if not hundreds of thousands of hosts. So for those cases, having to SSH into each one just to do monitoring is not very effective. So at Sysdig, we thought, what happens if we take all the system events that are coming from all the nodes in your system, and instead of keeping them on the local machine where Sysdig is running, let's correlate them to a central place. And what happens is what we call Sysdig Cloud. Sysdig Cloud is our distributed infrastructure monitoring and troubleshooting tool. So here I have pretty much the same infrastructure that I showed on my laptop, but it's running on several hosts. So here I have a group of hosts, and I can expand each one. For example, I can expand the Redis, and I get to a view where I see the host, and I can expand, and I get to a view where I see the individual container. So if I do this trick of expanding, now I can see all the containers, for example, HA proxy and WordPress, so I can very easily keep an eye on what's happening inside my whole distributed infrastructure. And this is not only limited to a scope like this, but since we are seeing all the system calls, we are able to get very rich application metrics. For example, I can click on the entire host, and zoom in into, I call a view HTTP. And this will show me all the HTTP requests that are served by the whole host. Or I can dig into one specific container, for example, HA proxy, and see just the HTTP requests served by this container. So we have tried essentially to mimic the workflow of Sysdig and Sysdig on a distributed environment. And we can also get to very advanced and cool visualizations. For example, one that we have by seeing all the network activity is by using, for example, this map, where I have a chart of my whole infrastructure, how it's behaving, a topological map where I can see clusters, and clusters are a group of hosts. And if I expand each host, I get to a view where I see the individual hosts. And if I expand each host, I get to a view where I see the individual containers. You can see here that I have and I can see that I have HA proxy talking with a bunch of WordPress containers, and I can expand and see the individual processes. So HA proxy talking to Apache. And this is all done from the boring flat list of system events that we saw at the very first in my very first use case, which seemed so useless. So the gist of it is that if you have a lot of data at your fingerprint, you can be very effective at doing monitoring and troubleshooting. And this is pretty much it. Thank you.
I think people really like your visuals there. That seems to be very popular. So if anyone would like to ask questions, I'm actually going to start off.
Yes.
How much overhead is it to get all of that information to a central server?
Okay, so what happens is that I lied. So when I say that we get all the system events to a central location, I didn't mean that. I meant that all the system calls are fetched in the node, then they are processed and summarized in a very small data structure, which is very compact. We are talking about a throughput of a few kilobytes per second, from 1 to 3 kilobytes per second, and is sent to the centralized location. But this compact structure contains all the things that you would like. Contains all the network connections, all the HTTP transactions, all the container list, all the Kubernetes layout if you are using a cluster orchestrator. So that's our reply to not getting your network completely overwhelmed by system calls.
Great, thank you. Anyone else have questions? Yes.
All right, so this was all described in the context of containers.
Yeah.
But would this be equally useful for, say, an HPC compute cluster where I want to correlate events between multiple physical nodes?
It can be, yeah, it can definitely be. I don't have a good use case, but again, essentially Sysdig can be very useful everywhere you have a Linux kernel. And just with containers, as I said, it becomes exponentially more useful because troubleshooting tools are historically not that good at containers, but you can apply the exact same workflow even if you are not running containers. Yeah.
Hi. To add to the question about HPC clusters, how much overhead does Sysdig bring to a single node? For example, if we have one of our users doing MPI stuff on multiple nodes, and we want to see what exactly is going on because things don't seem to advance, would that have a large impact on the running processes or the MPI stuff that's running?
Okay. So what happens is that the overhead can be divided in two parts. There's the kernel overhead, which is the overhead introduced by the module, the kernel drivers, sniffing system calls, and then the user space overhead, which is the one introduced by the user space application. When it comes to the kernel, we have been extremely careful at making it lightweight. In fact, you can barely expect a overhead in the capturing part. The driver is extremely small. I think that at this point it's about 2,000 lines of code, a little bit more than that if you exclude some boilerplate. So the overhead from the kernel point of view is completely negligible. From the user space point of view, if you're using the open source Sysdig part that I showed, it depends on what you're doing. If you're dumping on the disk a trace file where your NGINX server is serving 18,000 HTTP requests per second, you are going to saturate your disk, you are going to saturate the CPU because Sysdig is dumping dozens of megabytes per second, or if you run a chisel that wants to compute all the prime numbers of the universe, of course that's going to be heavy. For Sysdig Cloud, instead here, we are using the same kernel instrumentation, and we've wrote a very lightweight agent, so you can expect an overhead of just not more than a few point percentage of CPU, like 1 to 3%, something like that. And it's designed, and it's already working for a bunch of our users 24/7 on their production environment. So the answer is, with Sysdig, it's very powerful, and you can shoot yourself in the foot if you do some crazy analysis. Sysdig Cloud, no, is like just a completely isolated agent that you cannot interact with it. So it's what it does is just getting system call and summarizing it in the most efficient way.
Have any other questions? Yes.
Of what you've shown today, what's the open source and what's the commercial offering that you have? So
all the things that I showed on the command line, Sysdig, Sysdig, as well as the driver part is completely open source. You go on GitHub, all the development is open. We have an active community. We have external contributors. Sysdig Cloud, for the moment, is commercial because we need to sustain ourselves in some way. So Sysdig Cloud at this moment is commercial. Sysdig Cloud is provided as a software as a service or as an on-premise installation where you can deploy this whole thing locally and then deal with it and have the same and you would have the same exact experience either way.
All right, thank you very much. Everyone, please give him a round of applause. Yes.